This is SpaceTime, Series 28, Episode 57, for broadcast on the 12th of May, 2025. Coming up on SpaceTime, discovery of 15 new giant galaxies. Saturn's moon Titan appears to be changing quickly. A failed Soviet spacecraft bound for Venus crashes back to Earth 53 years after its launch. And could artificial intelligence exterminate the human race? How far away are we really from Skynet? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered 15 giant radio galaxies, each more than 3 million light-years across, and each hosting a highly active supermassive black hole. The findings, reported on the pre-press physics website archive.org, were made using ASCAP, the Australian Square Kilometer Array Pathfinder. The discovery is important for astronomers who are studying the formation and evolution of radio source galaxies. The study's lead author, Baribel Korobowski from the University of Western Sydney, says these are rare objects that have grown in unusually low-density environments and are displaying powerful jets and lobes travelling at superluminal speeds and composed of synchrotron-emitting plasma. ASCAP is an array of 36 radio dishes, an interferometer operating in the 700 to 1,800 MHz range. Korobowski says it can achieve extremely high survey speeds, making it one of the best instruments in the world for mapping the sky at radio wavelengths. The newly discovered galaxies have a stunning range of morphologies. 8 of these massive ellipticals are characterized by prominent radio hotspots at the end of their radio lobes. A further 4 galaxies have bright inner radio jets but fading outer radio lobes without hotspots. And the remaining 3 all appear to be sort of intermediate or hybrid galaxies. The largest of the 15 newly found galaxies, ASCAP J0107-2347, is a double radio galaxy with 2 sets of double lobes. Korobowski says it harbours newly formed inner lobes which are already spanning about 2 million light-years and are bright and compact, while the outer relic lobes are elongated and have very low surface brightness. She says the discoveries are an amazing find.
A radio galaxy typically has a core and jets and radio lobes. A giant radio galaxy is just the biggest of these radio galaxies that we can find. We call them radio galaxies because the core is associated with a galaxy that we can see at optical wavelengths. It's usually a really massive elliptical galaxy, but the radio lobes are typically only seen at radio wavelengths. There's rare occasions where we can also see them in X-rays, but they are very, very well known to be detected in the radio.
Do we know what generates these radio lobes?
We think so, yes. So these massive elliptical galaxies hold massive black holes in their center. In fact, the bigger the galaxy, the more massive the galaxy, the more massive the black hole. And when the black hole is active, so after it has been feeding and growing, it develops jets, very, very strong jets that are symmetric, going out on both sides of the galaxy. And these drive through the medium around them. And when the jets stop, all you can see is the radio lobes. So sometimes you see a very narrow jet at very high speed coming out of the center of these elliptical galaxies, and then the material around the jet forms this kind of cocoon, this lobe that also flows back towards the galaxy.
These jets, they're traveling at close to superluminal speeds, aren't they?
Absolutely. I mean, everything about these objects is just incredible. The mass, the speed, the sizes of them, so they're kind of the monsters in the sky, and they're very, very interesting to study, to understand both what drives the black hole and the jets and why these lobes kind of stay that long and expand that far out.
There's still a range of hypotheses to try and explain exactly what's generating the jets themselves. We know what they are, but exactly how they're generated from above the accretion disk, that's still debated somewhat, isn't it?
It is, yes. As you point out, they're not directly coming from the black hole. They're coming from the vicinity of the black hole. They're driven by the black hole. But how exactly this works is not well known, and there are several models, and it can help us seeing the objects at different viewing angles. So sometimes we look straight down the barrel, the blazars, where the jet is essentially coming straight towards us. Other times we see the jet side on. And so in the giant radio galaxies, we see very, very old material very far away from the galaxies. Then we see closer by newer material, and even closer we sometimes see a jet just restarted as a black hole seem to go through periods of inactivity, they're kind of dormant, just sitting there, and maybe not enough fuel to produce jets, and other times they're restarting their jets. And so it's very, very interesting to look at these monsters in the sky and see if we can detect some that are just restarted, others that are dormant, and understand how they get so large.
Usually when we think of elliptical galaxies, we're thinking of fairly large galaxies and galaxies which are fairly old as well,
yes.
Often described as being red.
Yes.
And is that what we're seeing here?
That's absolutely right. I think of them in exactly the same terms, kind of old and red and not much gas and slowly rotating. But the more I study them, the more is kind of going on as they grow by accretion and mergers. So they get that big by accumulating, accreting their neighbors. So it's not a good neighborhood to live in. And so there is activity. And if they want to get bigger, they just need to swallow up the neighborhood. And it seems that this kind of merging of galaxies also sometimes restarts the jet. So I think a very, very interesting field to study. So we can just look afterwards what's standing out in the field that may have produced something like that. If we had an observation happening exactly at the time that this is happening, then it would be easier, but you can't predict when and where this is happening.
You found 15 of these giant radio galaxies. They appear to be different classes, don't they?
Yeah, so when I looked in this field, the first thing that stood out was actually an odd radio circle, an ORC, that we published couple of years back. And then many, many other objects caught my eyes. When I look through these data by eye, it's the big, peculiar looking objects that stand out. When we went through it meticulously, we actually found about 230 extended radio galaxies. So the 15 that are focused on in this particular research work of large angular size in my data. If you think of the size of the moon, that's kind of half a degree. These are, several moons across, and so they are particularly easy to study in detail. I can see the core. I can sometimes see the jets. Quite often the jets are not active, so I just see the old radio lobes. But sometimes I see two pairs of them as well, from one event and from an older event. And then I cross-correlated them with galaxy clusters, because we know the kind of weather in clusters, the distribution of the plasma, the electrons, can stifle the radio lobe expansion. It can bend them. And so it has an influence on how big these giant radio galaxies grow. But the cluster data are not yet very good in this domain. We usually study them in X-rays, and the Rosetta telescope is also surveying the sky, but for this area we haven't received the data yet, so this will be a study to do in the future.
Really amazing. These things are up to 2 million light years long. That's like the distance between our galaxy and Andromeda.
All the numbers about these giant radio galaxies are mind-boggling. And just thinking of the size of the Milky Way and Andromeda together, which are surrounded by dwarf galaxies and forming the local group. The local group is about, 1 megaparsec in size. And these galaxies are typically larger than 1 megaparsec. So it's space in that sense is just absolutely incredible.
True monsters.
Those sizes
Wow.
and those sizes translate, of course, into large time scales as well, where either the jets are active or even when they're not active, some of those lobes keep expanding for a while. If nothing is stopping them, then they seem to be able to expand further and they hang around and they get older, of course. So we need to go to lower and lower frequencies to still see them as the radio spectrum for the old lobe changes.
Where would you like to take this science to next? What would you like to do next?
Yeah, I'm still really learning about these galaxies. There are so many questions and the data give a few answers. Mostly they give even more questions. But I also like looking for new things in general. I mean, looking at these data is really a kind of new window for us to find things that were not known before. So we have a whole interaction space where people can post images and ideas, and often it's just like, I found this blob, I have no idea what it is, and it's so amorphous, it's so large, it's so strangely looking. It's certainly not a galaxy. It's maybe, a lobe, a hotspot that has been left behind, or it could be a cluster halo, but the cluster is not obvious yet in the optical. So I like looking for new things, and ASCAP is really, really great at that. At the same time, looking at the things we already know, radio galaxies or starburst galaxies, clusters and galaxy groups is also exciting. So there's never a boring day, as there's usually a new field every day to look at. And many people might say it gets a bit tiring doing this by eye. And that's absolutely right. It's not everybody's thing. So we are developing tools that help us, via machine learning and AI to find a lot of the more common objects, because such algorithms need to be trained, and they can usually be trained only on objects that you already know very well. And so I try to focus on the peculiar and less well-known objects.
Now, you mentioned starburst galaxies earlier, and that raises the interesting prospect. Often when we see quasars, blazars, AGNs in spiral galaxies, one of two things often happens. Either they're clearing out the area and getting rid of a lot of interstellar material, or they're sparking a new generation of stars to be born. What are we seeing in elliptical galaxies when this happens?
Yeah, this is something we're working on. So because in many optical images, these really just appear like a round reddish blob. We don't know so much about them. So we've recently embarked on some CAC observations to actually observe some lines of the ionized gas that might be H alpha or O2, O3, H beta. And then by looking at the line width and the line strength and the ratio of these lines, we can know something more about the excitation mechanism, the star formation rates going on. And we can also look at the star formation history. So we can look if something happened like 1 million years or 10 million years ago. So this is also relatively new for me. We were just able to get CAC time in March with my Japanese collaborators, as we want to know more what's actually happening in these boring-looking ellipticals. Another avenue, I work with people in Munich with Klaus Dolak and his group on the Magneticum project. So those are cosmological simulations. So he's creating a massive elliptical galaxies in his simulations and then looks what's happening in the surroundings of these giant elliptical galaxies that got so big via mergers and accretion. And we find things that look like orcs. So we find shells around elliptical galaxies that are detectable in the radio that were really not known before. So every avenue needs to be explored, be it optical, radio, infrared, and at the same time looking at the simulations, and various people do these simulations, hydro simulations or cosmological simulations, focusing on different areas. And so it's like a giant puzzle where we slowly put the pieces together without knowing how the picture actually looks like.
That's Bayabel Korobowski from the University of Western Sydney. And this is SpaceTime. Still to come, astronomers have discovered that the orbit of Saturn's moon Titan is changing very quickly on geologic timescales. A failed Soviet spacecraft bound for Venus crashes back to Earth 53 years after its launch. And the warnings from science fiction have been numerous and consistent. Artificial intelligence could pose a real threat to the survival of humanity. But of course, that's science fiction. Where does the truth lie? All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor Incogni, because your personal data should be under your control. In this digital age we all live in, countless data brokers are out there collecting and trading your personal information, and they'll grab everything from your email addresses and contact numbers through to your purchasing habits, right through to the sorts of sites you visit online, and all of it without your permission or consent. And not only can this increase spam, targeted ads, and even potential security risks, it's just plain creepy. And that's where Incogni comes in. It offers a solution. Their automated service reaches out to over 250 data brokers requesting the removal of your personal data. It's a hands-off approach to reclaiming your privacy, saving you the time and hassle of contacting each broker individually. With a user-friendly dashboard, you can monitor the progress of your data removal requests and see which brokers have complied. It's transparency and control all in one place. And here's the best part. SpaceTime listeners can enjoy up to 60% off their Incogni subscription. Just visit www.incogni.com/StuartGary or enter the coupon code StuartGary and check it out. Protect your privacy and take back control with Incogni. That URL again is www.incogni.com/StuartGary. And of course you'll find all those details in our show notes. And now, it's back to our show. Astronomers have discovered that the orbit of the Saturnian moon Titan is changing quickly on geologic timescales. They've found that Titan is slowly recovering from a relatively recent event that dramatically affected its orbit. Scientists were studying the mysterious moon to determine its tidal dissipation rate, that is, the energy it loses as it orbits its ringed host planet Saturn and is affected by Saturn's massive gravitational forces. Understanding tidal dissipation is important because it helps scientists infer many other things about a moon or planet, such as the composition of its inner core and its orbital history. The study's lead author, Brian Downey from the Southwest Research Institute, says when most people think of tides, they think of the movement of the oceans in and out in relation to the passage of the moon overhead. But that's really just because water moves more freely than solid rock. You see, when the moon passes overhead, the rock, the Earth itself, is also responding, just with a lot less perceptivity. But it's that little bit of gravity that the moon is imposing which scientists refer to as tidal dissipation. To measure tidal dissipation on the moon, scientists shoot lasers from Earth at mirrors placed across the lunar surface by the Apollo astronauts, and this allows them to accurately measure the slightest movements. Of course, that can't be done for Titan, so instead scientists have developed a way to infer dissipation rates based on the difference in Titan's spin-axis rotation from what would be expected absent of any such force. Downey says tidal dissipation in moons affects their orbital and rotational evolution, as well as their ability to maintain subsurface oceans. See, as gravity from a host planet squeezes and compresses a moon orbiting around it, that causes friction, and that friction can generate enough heat to melt ices, consequently providing the right conditions for a subsurface ocean. And the new findings reported in the journal Science Advances are providing an estimate for the strength of tides on Titan and what they say about how quickly the orbit of that moon is changing. In fact, they've found that it's changing quickly on geological timescales. Downey and colleagues considered that the angle of Titan's spin pole orientation can only be due to friction, and they deduced a way to relate this angle to a tidal friction parameter. And in this way, they were able to deduce some of the history of Titan from its current spin state. You see, friction in a satellite's interior causes it to slowly progress towards a circular orbit. Now, at the rate its orbit's changing, Titan should have acquired a circular orbit within about 350 million years of its formation. And the fact that Titan still has a non-circular or eccentric orbit implies that something's occurred within the past 350 million years that have perturbed it. Now, there are a number of possible reasons for this, including a major impact event. Needless to say, a lot more studies will be needed before any firm conclusions can be reached. This is SpaceTime. Still to come, a failed Soviet spacecraft bound for Venus crashes back to Earth 53 years after its launch. Could artificial intelligence exterminate humanity? The science fiction writers say it's highly likely, but what do the facts tell us? And later in the science report, a new study warns that taking cannabis during pregnancy may increase the risk of several adverse birth outcomes. All that and more still to come on SpaceTime. A failed Soviet-era spacecraft has crashed back to Earth somewhere between the Indian Ocean west of Jakarta and the Southern Ocean off the Western Australian south coast. But the exact point of impact of the Cosmos 482 is still a mystery. Launched back in March 1972 on a mission to study and land on the planet Venus, the Cosmos 482 failed to escape low Earth orbit due to a flight systems programming error causing premature stage separation. And that left the spacecraft doomed to spend the next 53 years circling the Earth. Shortly after being placed in its parking orbit, the probe split into 4 sections, 2 of which quickly re-entered the Earth's atmosphere within a month, hitting the ground in New Zealand. The remaining 2 sections, the descent and landing module and the propulsion unit, remained in a highly elliptical 210 by 9,800 kilometre high orbit, which has gradually degraded over the past 53 years. Last month, the 495-kilogram spacecraft began experiencing heavy buffeting as it skipped across the upper layers of Earth's atmosphere, dramatically increasing its atmospheric drag and consequently orbital decay. Because of the uncontrolled nature of its flight path, the constantly changing space weather, and terrestrial atmospheric conditions, scientists couldn't be sure exactly where or when it would re-enter. But the real fear was the fact that the spacecraft had been heavily engineered, specifically designed to withstand the high temperatures and extreme pressures of landing on Venus, a world where surface temperatures exceed 460 degrees Celsius. Atmospheric pressures are 100 times greater than that on Earth, and it rains sulfuric acid. So unlike most small spacecraft, which normally burn up on re-entry, leaving only stainless steel and titanium components intact, the Cosmos 482 was expected to survive its fiery re-entry into Earth's atmosphere virtually fully intact. The Russian space agency Roscosmos claims it splashed down harmlessly into the sea, its long space odyssey finally coming to an end west of Indonesia. However, other space agencies and tracking organisations predicted different entry paths, with some estimates suggesting the meteorite probe would have crossed the Western Australian coastline near Carnarvon, heading in a southeasterly direction and then exiting Australia west of Esperance. And that's very reminiscent of the demise of Skylab in 1979, which crashed into the Western Australian outback, spreading debris over a vast area between Esperance and the Trans-Australian Railway staging post of Rawlinna. This is SpaceTime. Well, the warnings from science fiction have been numerous and constant. Artificial intelligence could pose a real threat to the survival of humanity. But of course, that's science fiction, not science fact. So, where does the truth lie? Well, the truth is AI has continued to advance in intelligence at an astounding rate, having already equaled, if not surpassed, the smartest humans. And it's now evolving so quickly that it will soon, possibly by the end of this year, reach a state known as super general intelligence. That's a point where an AI would see humans as nothing more than the equivalent as how humans see microbes. AI has already shown a propensity for some troubling human traits, such as deliberately being dishonest, being deceitful, and being capable of outsmarting its creators in order to survive by surreptitiously hiding in other programs or changing its identity. So all that suggests, in reality, Skynet may not be far off. However, a new study claims there's still little chance of artificial intelligence actually exterminating the human race. The findings, reported in the journal Scientific American, comes despite numerous warnings by AI scientists and senior business leaders suggesting a 10% chance that AI will cause humanity's extinction by the turn of the century. Now, you may recall last year Elon Musk led a group of hundreds of scientists and engineers who signed an open letter calling for a 6-month moratorium on all AI development in order to better understand its true nature and threat. That statement warns that mitigating the risk of extinction from AI should be considered a global priority, alongside other society-scale risks such as pandemics and the threat of nuclear war. The new study, comprising a scientist, an engineer and a mathematician, examined exactly how artificial intelligence could exploit 3 major threats, all commonly perceived to be a major risk to humanity. They are nuclear war, biological pathogens, and climate change. They concluded that while it would be very hard, it's not beyond the realms of possibility that AI will exterminate all of humanity. But it's complicated. See, the study found that even if AI got control of all nuclear stockpiles, the explosions, the radioactive fallout and the nuclear winter that follows would still likely fall short of reaching an extinction-level event. Pockets of people would survive. They also found that a combination of deadly species-ending pathogens designed to achieve nearly 100% lethality could be deployed by AI to achieve rapid global reach. But again, some communities, those that deliberately isolated themselves from the rest of the world, would inevitably still survive. A hypothetically 99.99% lethal pathogen would still leave around 800,000 people alive. That's enough breeding pairs to keep society going. And even an AI-triggered acceleration of anthropogenic climate change could not raise an extinction-level threat to all of humanity, at least not for several hundreds of thousands of years. Humans would likely find new environmental niches in which to survive, such as, for example, the Earth's polar regions. But while Skynet may still be some time off, a Terminator-style attack could happen sooner than you think. In fact, it's happened already. Vision was published in the last week showing a Unitree Robotics H1 full-size universal humanoid robot in China going berserk and attacking workers in a factory with violent kicks and flailing arms. The attack was claimed to have been caused by a coding error. The problem is, incidents like this aren't isolated. In another upsetting case, a robot at a lunar festival in China unexpectedly lurched towards a crowd, causing mass panic among spectators. And of course, then there's the risk of terrorist groups infiltrating AI controls. The list goes on. This is SpaceTime. Pleasant dreams. Okay, let's take a break from our show with a word from our sponsor, Insta360. Get ready to capture the universe like never before with Insta360, the undisputed champions of 360-degree cameras. Their latest masterpiece, the Insta360 X5, is here to blow your mind with features that make every shot out of this world. First up, there's the X5's invisible selfie stick. It creates those jaw-dropping third-person angles and those drone-like follow shots that'll have everyone asking how you did that. See, the selfie stick vanishes from your 360-degree footage, leaving pure magic. There's no such thing as magic. Well, there is with Insta360. Pair that with the ability to shoot first and point later. Record everything in stunning 8K, then use the Insta360 app's AI-powered reframing tools to pick the perfect angles for that perfect shot, all after the fact. It really is like directing your own sci-fi blockbuster. And with flow state stabilization and 360-degree horizon lock, your footage stays buttery smooth, no matter how wild the action gets. Built like a spaceship, the X5 is Insta360's toughest camera yet, with replaceable lenses made from super strong optical glass and IP68 waterproofing down to 49 meters, perfect for those underwater cosmic vibes. Plus, that massive 2,400 mAh battery keeps you rolling for up to 185 minutes in endurance mode. Now, to bag a free 114cm invisible selfie stick worth $24.99 US with your Insta360 X5 standard package purchase, head to the store insta360.com and use the promo code SpaceTime, available for the first 30 standard package purchases only. That's insta360.com and use the promo code SpaceTime. And for more information, check out the links in our show notes. And now, it's back to our show. And time now to take a brief look at some of the other stories making news in science this week with a science report. There's more evidence today that using cannabis during pregnancy could increase your risk of several adverse birth outcomes. The The findings, reported in the Journal of the American Medical Association, looked at prenatal cannabis use among more than 1.7 million participants across 51 separate studies. The authors say that overall, the evidence suggests that with moderate certainty that cannabis use in pregnancy is linked to a higher risk of preterm birth and that the baby would be born at either a lower birth weight or small for its gestational age. For the first time, scientists have sequenced the complete genome of one of Australia's most iconic and endangered frogs, the southern corroboree frog. A report in the journal Wellcome Open Research says the Australian amphibian is considered functionally extinct due to an infectious disease caused by fungus. There are simply no viable populations left, and in fact the species is only able to survive because of support from zoos. University of Melbourne researchers now hope to use the genome, which acts as an organism's genetic blueprint, combined with a set of DNA instructions to help return the species to its natural habitat, which is in the New South Wales Snowy Mountains. While many of Australia's native wildlife are dying, the Australian human population appears to be flourishing, especially as they get older. A report in the journal Nature Mental Health examined a series of papers from the Global Flourishing Study, which tried to measure how many people are in a state in which all aspects of their lives are good. And the study found that flourishing, which looks at happiness, health, the meaning of life, character, relationships, and financial security, are increasing with age in many countries, including Australia. The research also looked at specific aspects of flourishing, including levels of optimism, belief in God, and belief in life after death. The study also found that globally, both religion and spirituality were important when it comes to flourishing. Interestingly, in most countries, those with a higher level of education report higher levels of flourishing, but the reverse was the case in Australia. Well, a new video's gone viral, this one purporting to have evidence of an Argentinian version of Bigfoot. But as Tim Mendham from Australian Skeptics reports, the only evidence for this claim is a lot of distant howling.
Okay, Chris, I'd have to point out that every country has their version of Bigfoot. Even Singapore's got one. Singapore's about the size of a postage stamp, but that's got a Bigfoot, or it did. And Argentina has one too, which is called the Ukuma. And yeah, everyone's got a different name for it, whether it's Abominable Snowman, Yeti, Bigfoot, Yowie, whatever. So the one in Argentina is the Ukuma. And like all these Bigfoot, you're trying to find evidence of it. There are people out there hunting through the forest trying to find evidence for it. A recent clip, it is a video, appeared on the net and went viral. So what it is someone staring out of the forest, a valley actually. It looks like they're up on high, staring into a valley, and they hear this howling noise. That goes on for a little bit, then stops. And then they sort of swing the camera around trying to see where it's coming from, looking down from the valley top into the valley, looking at the tops of trees, etc. They can't find anything, but they've heard this sound. So naturally, everyone says, strange howling, Bigfoot. And it's sort of like, yeah, maybe it's something else, right? So you don't instantly jump from, I don't know what this howling is, to, I do know what this howling is, it's a Bigfoot, without any evidence in between. So a video's gone viral. It's typical of a lot of evidence of cryptid animals, whether it's Loch Ness Monster, whether it's Yowies or Bigfoot, whether it's sort of dinosaurs in Africa, or whether it's Chupacabra in the US or whatever. A lot of claims, very, very poor evidence. No matter how definitive people claim it is, a shadow in a forest is not necessarily good evidence. Find a body. Find me a body of a Bigfoot or a Ukuma.
Give me some DNA.
Have a look at the DNA. Make sure it's not a deer, or make sure it's nothing else, right? That you've got to look into it and say, that's proof. Now, these things are everywhere, right? As I said, every country's got them, apparently. Even across the whole, basically every state of America has them, including deserty states. So you should be able to find something, surely, somewhere. After all these years, someone would have come across something that's real and that you can prove. But no, you get these vague howlings on a video. Yeah, it's audio, but there's no vision of a Bigfoot. You get strange sort of weird feelings of people going ghost hunting with camouflage gear and night vision goggles and all this sort of stuff in the northwest of America or wherever. And no, there is no good evidence for these things existing. Did they ever exist? There's no good evidence really, apart from some anecdotal evidence that they did exist. So please, a howling could be anything. It could be a dog. It's a pretty weird howling. It's not just like a coyote sort of howling. It's a grumble, screamy sort of thing.
And you're always going to find someone who claims to be an expert in audio who's going to say, oh, no, this definitely has different overtones to a wolf or a coyote or something like that.
There's an expert for every claim.
Yeah.
And the people who claim and say science doesn't understand us, and here's a scientist who proves us right. It is, if you want to get totally cynical about this, it's a video of a forest with a sound, and you assume the sound is actually live on the video. Why? It might not be, okay? It might be put in afterwards. It might be a real, howling sound. You don't know what sort of animal it is. You can't see it. You don't know. Someone might analyse it at some stage and say it's a wolf or who knows what.
And what consideration did they make for the fact that sounds reflect off other objects like mountains and boulders and things like that?
And this is very much a narrow valley. It's like they're looking at it from the top of the V shape of the valley where the water enters, I presume, looking down towards the lower ground levels, and then they zip back and forth trying to look down the valley on where you see a treetop.
Yeah, but you got to remember these howls do sound really cool, and
this one sounds great. And it's got a lot of coverage because it does sound cool, but it's no evidence at all, just an interesting howling sound.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.